Is electromagnetism coming in this winter?
Yes. So what is coming to you guys is as a pre-flight, right? Remember, tomorrow is Friday, so there is a pre-flight, and the pre-flight has two parts. One part is a 7-segment display, and you just read one page on Wikipedia about it and watch a 2-minute video, so that we can start right away using the 7-segment displays to do interesting things on paper, okay? But we're only going to really do like half of it, okay? We're only going to do, if you guys are talking in the back, by the way, that's totally fine, provided you don't disturb people around you, okay? So be cognizant of that. I am fine talking over you. That's no problem, okay? But if you're disturbing somebody else, please, please be aware. All right, so that said, okay, another thing that's provided for you as a pre-flight is the list of learning objectives. Thank you. The list of learning objectives, and they are now, what the heck? Okay, that is really weird. I'm going to change them and repost them. They right now are all numbered. It's just something weird happened, and some of them are numbered. They're all numbered by lecture, like lecture 11, lecture 14, lecture 15, lecture 16. There are only 9 lectures that are covered between exam 1 and exam 2. How many of you are surprised by that? The content is only 9 lectures. We covered a ton of material in 9 lectures, okay? Because the other lectures were reviewed, okay? So there are only 9 lectures between exam 1 and exam 2, but it has a ton of learning objectives. And here they're numbered very inconsistently, A, B, on some lectures, and 1, 2, 3 for the other. You can still index them, but this is your homework, and it's for everybody. Everybody should be getting that in the email. Is for tomorrow, you know, write your comfort level with those objectives, okay? Like 5 is like, I got it, you know, and 1 is like, no clue, all right? And there will be a survey. We'll either do it with iClicker or on Compass, okay, to try to explain those things a little bit better, all right? So go through that. So there are 2 lectures of the 9 are on motors and generators, okay? 2 lectures of the 9 lectures are on motors and generators. Will they be on the exam? You better believe it. Otherwise, why did we waste time in class talking to you about it, right? If we don't want you to learn this stuff. All right, so yeah, so like induction, you know, I mean, the objectives are right there. But there are only a few problems here, okay? So the study guide will cover a few more. Yes? Oh, yeah, we can. Yeah, we'll see if anybody else at 17. Okay, actually, I don't need it. I have it. I can just go to the same page. Okay. 17, yeah, it's on the list. So that's a diode question. By the way, the size of these problems is about 4 or 5 of them to an exam. Okay, these problems. There's like 40, or there's more than 40 problems, because sometimes there are 2 to a page. Well, maybe there's about 40 problems. We already isolated like 6 were irrelevant. So even with that, there's over 30 problems, at least 6 exams, guys. Okay. All right. There's also the multiple choice exam from last semester and the study guide that's upcoming. But study guide will fill in the holes. You can study 80% of the material probably without it. All right, 17. Okay. So here's a circuit. 1 kilo, and there is a diode here. Minus VT. ID, and IX. Okay. All right, so sorry for a slightly sloppy writing, but I think it's more or less okay. You guys can probably see that. All right. What's going on here? You guys are all familiar. First of all, what do you immediately want to do based on part 1 of the course? I know, you know, based on teaching part 1 of the course, I have certain expectation. What's like the first thing you want to do? No, definitely not draw a loop, because mesh method we didn't even cover in the class. So like, well, we did do KVL to a degree, okay? But we went right away from it, moved away from KVL, and did something that's mathematically similar, which is called node method. Anybody? No? All right, get comfortable with it. It's faster. So the first thing I want to do is draw a ground. Okay, that's the first thing I want to do. Okay. All right. Okay. Then instead of talking about voltage drops, I can say this is at 5 volts. Okay. So this sits at 5 volts here. Okay. This sits at 5 volts. What's this going to sit at? We don't know yet, right? Well, it depends on the behavior of the diode, right? Okay, how's the voltage going to fall through the resistor? So this is positive 5 volts. So maybe we can draw a current here, right? Are these two current sources, as far as this resistor is concerned, are these two current sources fighting against each other? What I mean, do they want to have the current through that resistor in the same direction or opposite? Same direction. So to me, the way I would like, one of the earliest things I would do is I would draw a current here, okay? Just call it I or something like that. I don't know, without even knowing what they're asking about, okay? Because I know current's going to be going this way, right? Okay, all right. And let's see.